Hello. In this class, we are going to learn some concepts in number theory. Number theory is one of the important concepts for all ninth and 10th class students in IIT concepts. It is the very difficult concepts are there in IIT standards. And here I am going to tell you, I am going to explain you some important concepts in the number theory, that is prime factorization of a number. So this is one of the interesting concept and very important concept for all students who are in 9th and 10th class. 9th and 10th class. So you know that according to the fundamental theorem of arithmetic, we can write a number as the product of its prime factors. But on the basis of this prime factorization, in our IIT concepts or in our competition exams, whatever it may be, there are so many difficult questions they will ask you. So while solving those questions, students face some problems. So on the basis of those concepts, here I am going to teach you some important concepts on the prime factorization of a number. Here, n is a composite number. Here I have taken one number as n. So here, if n is a n is a composite number, if I write its prime factorization, so that may be in the form of a to the power of p into b to the power of q into c to the power of r. Here a comma b comma c are the prime numbers, and these are whatever it may be p q r are the numbers. So I mean positive integers, whatever it may be. A n, when I write if the product of prime factors, as it will be a to the power of p into b to the power of q into c to the power of r, where a comma b comma c are prime numbers. I mean, for example, if I take 120, I can write this is 2 into 60, 2 into 30. So 2 into 15, this is 2 into 2 to the 4, 4 to the 8, 8 to the 16. I mean, 2 into 30, I mean 2 into 60, 2 into 30, and 2 into 15, 15 means 3 into 5. So this is 2 to the power of 3 into 5 to the power of 1 into 5 to 3 to the power of 1. So this is the prime factorization of 150. Like that, according to the fundamental theorem of arithmetic, we can write a number as a prime factors, product of its prime factors. So here also n is a composite number. So I wrote as a prime factorization as a to the power of p into b to the power of q into c to the power of r. Here some different types of questions he will ask you. If a number, he will give you a number, and sometimes he will ask you what the total number of factors of that particular number. So sometimes he will give you some big numbers, or sometimes he will give you directly its prime factorization, and he will ask you what are the total factors of that number. Here I taken one example, that is n is my number. If I make the prime factorization of this number is 2 to the power of 3 into 5, 3 to the power of 5 into 5 to the power of 2 into 7 to the power of 4. So if the prime factorization of n is like this, the first concept is how to find the total number of factors of n. I mean, this is my n, and you require to find the total number of factors. So those factors may be even factors or odd factors, whatever it may be. Here he is asking what is the total number of factors. He is asking total number of factors. So total number of factors, simply you can find, that is the formula. If you compare these two numbers, this is the total number of factors is p plus 1 into q plus 1 into r plus 1. So if you concentrate on the exponential values of the prime factorization, by that you can find the total factors of that particular number. So 2 to the power of 3 is there. In place of p, it is 3 is there. Total number of factors is 3 plus 1 into 5 plus 1 into 2 plus 1 into 4 plus 1. So this, if you multiply these values, you will get the total number of factors. So it is 4 into 6 into 3 into 5. So you know that 4 5s are 20, 6 3s are 80. So this is 360. So 360 indicates us this my number n is having how many factors are there? 360 factors are there. This is total number of factors. It is not even factors or not odd factors. Total number of factors of that particular number n is 360. By using this formula, p plus 1 into q plus 1 into r plus 1, where p comma q comma r are the exponential values of the prime numbers, I mean prime factors, So by using those values, we can find the total number of factors of the given number. So this is very interesting concept. So many times he will ask you the total number of factors of the given number. So like this, we can find the total number of factors by using this formula. So just I will write here the total number of the factors of this given number is 360. This is the total number of factors of given number. Sometimes he will ask you what are the total number of factors of that particular total number of prime factors he will ask you. Total number of prime factors he will ask you. Here the total number of prime factors, just you required to add the exponential values of the given product, I mean prime products. Here a to the power of b, b to the power of q and c to the power of r, where a comma b comma c are the prime numbers I told you. Then if you want to find the total number of prime factors, just you require to add the exponential values. I mean, this is the total number of prime factors is 3 plus 5 plus 2 plus 4. That is equal to 3 plus 5, 8, 10, 14. So the total number of prime factors is 14. So the total number of the prime factors of the given number is 14. So after this class, you take one any number and you make it as a prime factorization, and I will practice by using these formulas, and you will get the total number of factors of that particular number and total number of prime factors of that particular number. So like this, we can find the total number of prime factors of the given number. So this is the formula. The formula is p plus q plus r, where p comma q comma r are the exponential values of our prime factors. The next interesting concept is sum of all factors of given number. Sum of all factors of given number. It is somewhat difficult. It is the formula is a to the power of p plus 1 minus 1 by a minus 1, b to the power of q plus 1 minus 1 by b minus 1, c to the power of r plus 1 minus 1 by c minus 1. If you require to understand this formula, just you concentrate the prime factorization of given n, that is a to the power of p into b to the power of q into c to the power of r. These values you want to substitute in this formula, then you will get the answer. So according to this, a is the base and p is its power, and b is the base and q is its power, and you substitute those values. If this n is 2 to the power of 3 and 3 to the power of 5 and 5 to the power of 2 into 7 to the power of 4, then I can write the formula value of this. I mean, sum of all factors of this number is, the first one is a to the power of p plus 1. So a is my 2. 2 to the power of 3 plus 1 minus 1 by 2 minus 1. So a to the power of p plus 1 means 2 to the power is 3. 3 plus 1 minus 1 by 2 minus 1 into b to the power of means 3 to the power of 5 plus 1 minus 1 by 3 minus 1. Next one is 5 to the power of 2 plus 1 minus 1 by 5 minus 1 into 7 to the power of 4 plus 1 minus 1 by 7 minus 1. So if you require to simplify this one, so you will get the large number, I mean big number, and you need to calculate like this: 2 to the power of 3 minus 1 by 1 into 3 to the power of 6 minus 1 by 2. Next to 5 to the power of 3 minus 1 by 4 into 7 to the power of 5 minus 1 by 6. So if you calculate this, you will get one value. 2 to the power of 3 is 8. 3 to the power of 6 value you want to calculate, and 5 to the power of 3 is 125, and 7 to the power of 5 you want to calculate, and you require to simplify all this. So the denominator should be 2 4s are 24, 2 4s are 8, 48. The denominator will be 48. This is 8 minus 1. This becomes 7 into 3 to the power of 6 minus 1 into 125 minus 1 into 7 to the power of 5 minus 1. Just due to the length of my video, I am not doing the calculation. So 7 into this value minus into this value, you divide 48. You will get the sum of all factors of the given number. Here I taken one example as a big number. So sometimes it will give you some small number. If it is 2 to the power of 3 into 5 to the power of 5, it is easy to find the sum of all its factors. So this is the formula to find sum of all its factors. So this is also very interesting question. Sometimes he will give you one number and he asks sum of all its factors. Sometimes you may ask the total number of factors, sometimes you may ask the total number of prime factors, and sometimes he will ask you sum of all factors of the given number. So you want to use this formula and you substitute those values and you want to calculate, you will get the sum of all factors of the given number n. The next concept, it is very, very interesting. Sometimes the before concept I told you how to find the sum of all its factors. But sometimes he will ask you what is the product of the all factors. I mean, what are the product of its all factors? It is very easy to find the product of all factors of n is n to the power of total factors. I already told you the total number of factors of n is given, that is 360. If you want to find the product of all its factors, means the formula is n to the power of total factors by given. This is in power, total factors by 2 is in power. So you want to substitute those values in this power, then you will get the product of all its factors. For example, total factors. You require to find the total factors. I already find that in the first concept only. Total number of factors of the given number according to this formula you got 360. Now n to the power of 360 by 2, that implies n to the power of 180. So this is your answer. So this number, the prime factorization of this number is 2 to the power of 3 into 5, 3 to the power of 5 into 5 to the power of 2 into 7 to the power of 4. So according to this formula, product of all its factors becomes n to the power of total factors by 2. So total factors already I found, that is 360. Just you substitute the 360 in this formula, that is 360 by 2, then you will get n to the power of 180. By using this formula, you can find the product of its all factors. The next chapter, concept, I told you this is the total number of factor of the given number, that is 360. But here the total number of odd factors of the given number. The total number of odd factors of given number. This is very, very interesting and this is very, very important also. So many times this type of question is asked. This is, you want to concentrate total number of odd factors. Total number of odd factors. This is very important. Odd factors is asking. The formula is p plus 1 into q plus 1 into r plus 1. Here, while using this formula, you want to accept 2 to the power of something. In my prime factorization, 2 to the power of something is there. You should not count this one because 2 is an even number. You should not count those even numbers as the count in this total number of odd factors. So here my formula is p plus 1 into q plus 1 into r plus 1. So you should not count 2 to the power of values. So my answer is the total number of odd factors is p plus 1. You should not take 2 to the power of 3 because 2 is an even number. First you want to take 5 plus 1 into 2 plus 1 into 4 plus 1. This is the value to find the total number of odd factors of the given number. Now you can write this is 6 into 3 into 5. So you know that 6 5s are 30. 30 into 3 is 90. So there are 90 odd factors of the given number. There are 90 odd factors of the given number. So by using this formula, you should not count 2 to the power of this because these are all even factors of the given number. But he is asking what are the odd factors. Total number of odd factors he is asking. Just you want to apply this formula, but you should not count 2. So 2 to the power of 3. Just I counted 3, 5, 7 because these are all odd numbers. Therefore, this power is 5, 5 plus 1. This power is 2, 2 plus 1, and this power is 4, 4 plus 1. If you calculate it, you will get the 90. 90 is the answer, that is the total odd factors of the given number. And the last one, if you take the last one, total number of even factors. This is very, very interesting. There is no separate formula to find the total number of even factors. Simply you can find if you know the total factors. I already know the total factors of the number, that is 360. Already in the first case and in the first concept only we find that the total number of the factors of the given number, that is p plus 1 into q plus 1 into r plus 1 is formed. So if you calculate that, we got 360. That is the total number of factors of the given number. And we know the total number of odd numbers, the odd factors, total number of odd factors of the given number, that is 90. So now he is asking total number of even factors. In exam, if we ask the what are the total number of even factors, means 100% you required to find the total factors and you want to find the number of even factors. Then only you can say the total number of even factors of the given number. The formula is total factors minus total odd factors. So the total factors is 360 minus total odd factors is 90. This becomes, you know that 360 minus 90, 270. There are 270 even factors are there for the given number. So number system is one of the difficult chapter. There are so many interesting concepts are there in the number theory. In number theory, for particularly for IIT and in competition exams, they will ask you different types of questions. In this class, just I taken the prime factorization of a number and how to find the number of factors of a given number and how to find the prime factors of a number of prime factors of the given number and how to find the sum of its factors and how to find the product of its factors and how to find the odd factors of the given numbers and how to find the even factors of the given numbers. So by using these important formulas, if you apply on the prime factorization of the given number, you can find easily according to the given question. So you concentrate on these formulas and you wrote all these formulas in your books and you practice, you take some numbers and you practice these formulas and it is very, very easy to find all these concepts. Thank you.